Yeah. So in this question, they ask you to show w to the power of k is the solution of w to the power of 7 minus 1 equals 0. Yeah. So for the unity of roots, we talk about this so many times. So whenever you saw w to the power of n equals to 1, you don't even need to look at the questions. There are 3 things you immediately write them down next to the exam paper. Okay. So whenever you say w to the power of n equals to 1 or w to the power of n minus 1 equals 0, there are no difference, right? You just write down 3 things. Okay, you just write down 3 things. Yeah, first is w equals to 6, 2 pi over n, okay, because w is the first non-zero argument, right? The second is the sum of all the roots equals 0, so 1 plus w squared plus da 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 plus w to the power of n minus 1 equals to 0. Okay. And also because w is a solution, so when you substitute w into the equation, equals to 1. So you have w to the power of n equals to 1. Okay. Yeah. So if we want to show, so for the first question, okay, if we want to show w to the power of k is a solution, you just substitute w to the power of k into that equation. But before, when we have w to the power of 7 minus 1 equals 0, we have w to the power of 7 equals to 1. Okay, so this is kind of like a given. So every single power 7, it equals to 1. Okay, so we know this information. So just going to substitute w to the power of k into the equation and trying to solve it. So the left hand side equals to w to the power of 7 minus 1, which is w to the power of k, all to the power of 7 minus 1. And then just using index laws, we can switch those two positions. So w to the power of 7, all to the power of k equals to 1. Yeah, w to the power of 7 is 1, we just said it. So it's 1 to the power of k minus 1, which is 0. Okay, which equals to right hand side. Yeah, so w to the power of k is w to the power of k is a solution. Okay, if k is any integers. Okay, and then second, ask you to find the quadratic equation. You have the roots alpha and beta. So if you have a quadratic equation whose roots are alpha and beta, the general solution, the general equation, not the general solution, will just be a x squared minus alpha plus beta x plus alpha beta equals 0. Yeah, remember we have the restrictions on a. A doesn't equal 0 and a is any real numbers. Yeah, so this include all the quadratic equations whose roots are alpha and beta. Okay, because we said the linear coefficient is a negation of the sum, and then the constant term is the product of all the roots. Yeah. So and in the question they also give it to you alpha plus beta equals to w plus w to the power of 2 plus w to the power of 4, and then plus w to the power of 3 plus w to the power of 5 plus w to the power of 6. Yeah. So w to the power of 7 minus 1 equals 0. You have 7 roots. Okay, the sum of all the roots equals 0. Okay, so w to the power of 7 minus 1 equals 0. The sum of all the roots will equals to 0. Okay, the sum of all the roots equals 0. Yeah, so you can see we're just missing one root. Okay, we're just missing one root. The only roots missing is 1, right? So what I will do here is I will add a 1 and I will subtract 1, just to make sure everything stays the same. Okay, add 1 and subtract 1. So when I add 1, this is all 7 roots, right? Yeah, and then we said the sum of all the roots equals 0. So all the 7 roots equals 0. So 0 minus 1 equals to minus 1. Okay, so alpha plus beta is minus 1 because I already have all the roots. 1, w squared, w to the power of 3, w to the power of 4, w to the power of 5, and w to the power of 6. Now I just need to figure out the product of all the roots. So I have the alpha multiplied by beta. Okay, which would be the product of all the roots. Yeah, which is w plus w squared plus w to the power 4 multiplied by w to the power of 3 plus w to the power of 5 plus w to the power of 6. Yeah, so this one you just need a lot of multiplications. Okay. Yeah, we'll do it slowly one by one. Hopefully we'll get it. Yeah, we'll get to somewhere. Okay. Yeah, so first of all use w multiplied by all of this. So get w to the power of 4 plus w to the power of 6 plus, okay, so w plus w multiplied by w to the power of 6 is w to the power of 7. So you can just directly write down a 1, right? Directly write down a 1 plus, and then using w squared. W squared multiplied by 3, 5, 6. So everything is going to increase by 2. So w squared multiplied by w to the power of 3 is w to the power of 5. And then 2 and 5, 7 become 1. Okay, w to the power of 7 is 1. W squared multiplied by w to the power of 8. And then w to the power of 8, you're just going to reduce it to w. Okay, anything beyond 7, you just always minus 7. And then in the end, we have w to the power of 4 multiplied by all of them. So 4 and 3, that's just 1 again. Okay. And then 4 and 5, that's 9. 9 minus 7 is w squared. And then 4 and 6, that's 10. 10 minus 7 is w to the power of 3. Right? It's w to the power of 3. So how many 1 do we have? 1, 2, 3. Okay? 3. Okay. And then look at the rest of the w's. We have w squared, w to the power of 3, w to the power of 4, w to the power of 5, and w to the power of 6. Yeah, so we have all the roots except 1. So the sum of all the roots, you can plus 1 minus 1 overall just equals to minus 1, right? Yeah.
Do we need to justify why we like minus 7, or can we just do it?
You don't need to justify it, because w to the power of 7 equals to w to the power of 7 minus 1 equals 0. Yeah, so w to the power of 7 equals to 1. If you want to write one more step, you can do that. But other than that, yeah, every single time when you say w to the power of 7, you can just reduce it to 1. Yeah, so alpha multiplied by beta equals to 2. Yeah, so the constant equals to 2. And then the sum of the two roots equals to minus 1. So all the roots will get us a quadratic equation where we have a x squared plus x plus 2 equals to 0. Yeah, so this is the final answer. And then there's restrictions on a. A can't be 0, otherwise you won't have a quadratic equation anymore. And a can be any real numbers. Okay, a can be any